Hello, this is MechTech Mike here with a video to demonstrate a successful first integration between Rhino, RhinoCam, and the Centroid Acorn CNC controller. I've been using Rhino for some time for my design work, primarily with 3D printing. I wanted to move into CNC milling and bought a Precision Matthews PM727 manual mill with the intention of converting it to CNC. This video shows how I took a design in Rhino, laid down tool paths through the RhinoCam plugin, and generated G-code for use by the Acorn CNC controller. As some background, I started my CNC conversion by modeling the PM727 mill in Rhino, taking copious measurements to render the mill accurately. From there I designed the X and Y axes around the mill's dimensions, replaced the factory Acme screws with low-profile C5 ball screws, and built custom nut brackets as well. I used aluminum squared tubes as housing for the ball screw couplers and supports to hold the motors. I want to give a quick shout out to CNC4XR7 for making a set of outstanding YouTube videos for his conversion of his PM727 that served as inspiration for my own design. Once the design was complete, I began milling parts and integrating the ball screws and motors together. This included opening room for the ball screw nut, drilling mounting holes for bolts and support bearings. Most of the parts were milled manually, but for a few parts I got help from my buddy who had his own CNC machine. For the motion controller, I initially was considering a Mach 3 or 4 setup, but a new product came out last year from Centroid, the Acorn motion controller. This do-it-yourself product leverages motion control software from Centroid's industrial-grade products, promising superior performance potential. As Centroid provides both the hardware and software, I found the Acorn product to be well integrated and well supported. You can check out the product at this web address shown on the screen. For the Z-axis, I was concerned that the weight of the mill head, which is in excess of 100 pounds, would contribute to early wear out of the ball screw. So I designed a counterweight system in Rhino. As I had the basic X and Y axes up and working, I set out to mill some of the parts, setting the Z-axis manually. The part demonstrated in this video is the main housing of the pulley assembly, and the machining operation is to bore circular holes in the houses for the servo drive for the Z-axis. Once I designed all the parts in Rhino, I used RhinoCam plugin to lay down tool paths for the machining operations. In this basic example, I defined a 1/2-inch roughing mill tool in the RhinoCam tool library and defined 2 hole pocketing operations using this tool. The initial step requires orienting the part for the machining operations by putting the center of the circular holes at 0 for X and Y. In retrospect, I could have placed the part edges at 0 and simplified the part locating operation with the mill. But as this was a first effort and a learning experience, I was able to make easy sense of the resulting G-code output when I reviewed it later. For the 2-hole pocketing operations, RhinoCam provides an easy interface to define the control geometry by simply selecting the part edges to mill. From there, you can accept or override default parameters such as direction, overlap, and finishing for the operation. This includes part material definitions for setting speeds and feeds. RhinoCam creates the toolpaths and then graphically represents them in the design window. To validate the toolpath, RhinoCam provides a toolpath simulator using the defined tool and shows each movement that is commanded by the toolpath. From the defined operations, I posted the toolpaths to a G-code file. RhinoCam already came with Centroid's post setup and produced a complete G-code file intended for the Centroid Acorn controller. The generated G-code file pulled right into the CNC12 software. After setting the part center using a wiggler and the CNC part setup feature, I ran the G-code file. I was thrilled that this first end-to-end integration with design using Rhino, manufacturing using RhinoCam, and part production using Centroid CNC12 went flawlessly. I had no issues with the program compatibility throughout this experience. You can see in the video the mill going through its paces with the CNC12 software showing the progress graphically. What is impressive is that this feature of the CNC12 is not a simulation of the G's code, but a real-time interpreter of the G-code itself. As such, you get a detailed sense of the machining operations, providing important entry and exit motions, tool chains notifications, and where appropriate, spindle speeds changes. I show the machining operations at normal speed to provide a real-time sense of the operations. I'll speed up the operation to advance to the completion of the mill cycle here. So there you have it, a first successful integration of Rhino, RhinoCam, and the Centroid Acorn CNC controller. A special thank you to Centroid for their wonderful product and support, as well as the inputs and help from the quickly growing community of Acorn users. I've already taken the next steps with more complex parts and machining operations, and I'm gaining a lot of experience fast. Thank you for your interest.